Welcome to Spring Lib.
We know that the time period t equal to 2 pi into root of m upon k. So we are given information about Vx at some particular x. So the expression relating these two quantities come from the conservation of energy. Conservation of energy. So that is half mvx square plus half kx square equal to half ka square. So this gives you the conservation of energy. So we can solve this equation for root of m by k and then use that result to calculate t. Okay. So what we are going to do is, you have to be very careful with that. First we are going to solve this equation for root of m upon k. And now after solving this, we are going to use this result to calculate t. Okay. Now mvx square equal to k into a square minus x square. Okay. It gives root of m upon k. So root of m upon k equal to root of a square minus x square upon dx. So we are putting the values root of bracket open 0.100 meter the whole square minus 0.060 meter the whole square upon 0.400 meter per second. So remember, first we are going to find out the value of root of m upon k. Okay, so that is equal to 0.200 seconds. Okay, now when we have already found out m upon k, that is this. Now we can find out t, that is 2 pi root of m upon k, that is 2 pi into 0.200 seconds. That will be approximately equal to 1.26 seconds. So this is the answer for the A part. Okay, this will be the answer for the A part of our question. So this is our A part. Okay. Now let's move on to the B part of it. Understood? Root of m upon k we have found out. Then we have found out the value for t. Okay. Now the B part. In B part, you can see that we are asked to relate x and vx. So we have to use a conservation equation. Conservation of energy, that is half mvx square plus half kx square equal to half ka square. So what we can get, we are cutting all this down here. So it becomes mvx square plus kx square equal to ka square. Also we can also write it as kx square equal to ka square minus mvx square. So from here we can get x, that is equal to root of a square minus m by k vx square. Okay, so we have got this equation. Now we have to put the values for that. So how do we put the values? That is x equal to root of, it's a long one, so let's put it like this, root of 0.100 meter square minus 0.200 second square into 0.160 meter per second square. When we calculate, we are going to get the answer 0.0947 meter approximately when we calculate. So here we understand smaller Vx means larger x. Smaller Vx means larger x. So with this we have completed our B part. Let's move on to the C part of the question. In this C part, if the slice doesn't slip, the maximum acceleration of the plate equals to the acceleration of the slice of the plate will be equal to the maximum acceleration of the slice. Now, which is determined by using Newton's second law to the slice. Okay. Now, for the plate's case, minus kx equal to max. Hence, ax equal to minus of k by m into x. So, with this, the maximum is a. So, maximum acceleration will be, a max will be k by m into a, amplitude. The maximum height would be the amplitude. So, the maximum acceleration will be k by m into a because it is k by m into x. Okay, understood this? Now, if the carrot slice doesn't slip, okay, then the static friction force must be able to give this much acceleration. If doesn't slip, should give the maximum acceleration. So the free body diagram we have to see. This is very important, the free body diagram for that. So be very careful in understanding how does that happen. So this is the free body diagram, the y coordinate, okay, the x coordinate, the acceleration, we have the unit vector here. Now fs equal to mu n, this is the x, this is the y coordinate, and we have the downward force, that is m dash g. So sigma fy equal to may, n minus m dash g equal to 0. Therefore, n equal to m dash g. Okay. Now, this is sigma fy. We have sigma fx to be max. That is mu s n equal to m dash a. That is mu s m dash g equal to m dash a, and a equal to mu s g. But what we require here is, we require that a should be equal to a max, which is equal to k by m into a, that is equal to mu s g. Now, and mu s equal to k by m a by g, that is equal to 1 upon 0.200 seconds the whole square into 0.100 meter upon 9.80 meter per second square. Now that is equals to 0.255 approximately. So we understand that we can also write it as this. We can write that mu s equal to omega square upon the omega square A upon G. So more friction is required if the frequency or amplitude is increased. More friction is required if frequency and amplitude is increased. So this is the